Welcome to the demonstration of the latest developments in ANSYS concerning the crash and safety analysis field. The first advancements we will focus on are regarding ANSYS mass calculation capabilities. A new option was added in order to show the mass and inertia of any include or model in ANSYS. So we'll start by opening the deck report and the deck information window pops up. We enable the masses and open the include settings by clicking right here. This is the deck information configuration table, where we can see the available fields and drag and drop the ones we are interested in from the left to the right column. For example, let's select the total mass, the scaled mass, added mass, mass area, and finally the increment percentage. Now we can also change the order by dragging and dropping, and after reordering the fields however we wish, we click the OK button and then the Cancel button in order to close this window. For example, let's search in the includes list the wheels include. We right-click on it and open the report, where we can see the mass of the include of interest, depending on the selected fields we set earlier. This also works for multiple includes at the same time. Let's select two includes and right-click to see their deck reports. There is the information on each include as well as a total line where the sum of their masses is displayed. The same applies when it comes to models. Again, for one or multiple models, we can right-click, select report and see the final mass report for the same selected fields. There is one more new option, which can be activated in the Settings menu. In the Decks tab, there is the possibility to skip entities with undefined properties, material or property section during mass calculation. By enabling it, clicking Apply and then OK, we can go to Models and open the report for the selected model. We can see that there is a message warning us that in this case, undefined properties and materials are not taken into account for the mass calculation. Let's see what's new concerning the fringe plots. This is a load entity in Elsteiner, which applies to the tires in the direction of the arrows. By enabling the fringe view mode and selecting the Elements and L-Press option, we can see that the load shell entity now has a designated fringe plot. Furthermore, there is now the element L form, which can be shown as a fringe plot. Finally, the elements integration points are also available as a fringe plot. Let's see a few things about the includes. In a new ANSYS session, include, right-click, import and select the main file structure option. In this case, we will use the model of a Nissan Rogue. So select the main file and press OK. In the includes list, right-click on the engine assembly include to load the model. We can now see the parts in the graphics area. Let's go to the database and change the characteristic of some of the model's parts. For example, set the thickness of some properties as 2. We will also create boundary SBCs on some nodes, like so. Then move the boundary sub-include from the out of include section to the engine assembly include. Now if we click the Find Changes option, the Changed Includes window pops up and we can see what has been added or changed in the engine assembly include. The newest addition is that we can right-click on the modified include and output from this list. Let's try loading the wheels include by right-clicking and selecting the Load in Model option. The newest addition in this version is that by right-clicking on the include, we can directly find changes with file. In other words, we now have the ability to directly compare an include that exists in our database with an include which is saved in some other directory. This is the modified include, so by selecting it we are able to see the changes that occurred in the Changed Includes window. Of course, there is the ability to output the wheels include as a single file by right-clicking on it and following the known process. Let's take a look at one last feature. If we right-click on an include and select Replace, Import Files or Load in Model, we have the option to check the In Preview Mode checkbox. By enabling it and click the OK button, a Merge Models window pops up where all possible conflicts are displayed regarding IDs, names, or miscellaneous conflicts. Now for the clipboard. The clipboard container is a new entity within ANSYS, and it does not affect any other DEC containers, such as sets or includes. To begin, the includes list is accessed, and the wheels include is isolated. Next, the option to create a container for the entities related to the wheel, including elements, parts, and sets, is selected. We click the Pick button to select all the relevant entities, followed by a right-click to send them to the clipboard. The clipboard list then appears, displaying the selected elements. We close the list by confirming with the middle mouse button. The clipboard button is pressed again to reopen the list, and we double-click on the element shell. In this section, the PID field is made available. Of course, as with any ANSYS list, any desired field can be selected as needed. The list field option can also be used to select additional attributes from the elements card. Right-clicking on the PID field and selecting Open reveals all the properties associated with the elements already inside the clipboard. These properties can be selected and then dragged and dropped into the clipboard container. By double-clicking on the Parts section, the MID column appears. We can open a list of materials associated with the wheel by right-clicking on the MID field, which can also be dragged and dropped in a clipboard container. Furthermore, right-clicking within the container and selecting Reference will display all entities that are referenced by those contained within the clipboard. We then need to drag and drop into the container all the loads applied to the wheel, as well as sets that reference the entities of the wheel. At this point, all entities related to the wheel are successfully contained in one self-contained clipboard entity. The option to modify the contents remains available. Additionally, we can output the entities to a key file or save them as an ANSYS database using the Save As option. The following section highlights some key aspects of the checks. In this demonstration, the engine assembly has been isolated, and the mass entity is enabled, allowing for the visibility of all mass entities. Upon opening the relevant section, two mass entities are defined. For the purpose of this demonstration, the Pick option is used to view one of these entities. In this scenario, we have defined two mass entities, which are duplicated. Running the LS-DYNA checks reveals a warning for duplicated element mass definitions. Another significant check update is the change in the treatment of properties referencing undefined materials. This is now classified as an error, rather than a warning, ensuring greater clarity for users. Furthermore, a new check has been introduced for certain entities, such as nodal and rigid body entities. For example, rigid bodies should, by default, contain only rigid properties. Users are typically expected to select rigid properties for these entities. However, a modification now allows the selection of non-rigid properties as well. This check is now implemented as a warning for the user, signaling a deviation from the expected behavior. The rationale behind this change in the behavior of these specific entities is that materials may reside in different includes. It is possible that one include contains the rigid properties, such as those for constrained rigid bodies, while another include contains the materials. As a result, an undefined material may be assigned, potentially a non-rigid one, if the materials include is not loaded. This adjustment is made to accommodate such cases, allowing for greater flexibility in selecting properties. Thank you for your attention.